We got one here about real gases and how
Okay.
closely they resemble an ideal gas. So
I
how
like
would,
that one.
yeah, what am I looking for in this? How does something resemble an ideal gas?
Okay, so ideal gases, another name for ideal gases that we have
Normal
is
gas?
noble gases. Okay? So right off the bat, you should see that there's 3 there that are noble gases. Correct?
Uh-huh.
Let's go ahead and list everything that's there. So what do we got?
We have neon,
Okay, we got neon,
helium.
helium,
I think this is ammonium.
ammonium. Wait,
Ammonium.
ammonia?
H3.
Okay, that's ammonia.
Oh, ammonia.
Okay,
N2.
N2,
Carbon monoxide.
and carbon monoxide.
What do you call N2?
N2 is just nitrogen gas.
Nitrogen gas.
Because nitrogen is a diatomic molecule,
Yeah.
it's found in,
Yeah.
as in pairs in nature. So, the thing is, to be an ideal gas,
It has a full valence shell.
that,
Eight.
but these all have full valence shells, but ideal gases
Okay.
are also called inert gases.
Okay.
Okay, inert means that they don't
Yeah, they don't react.
they don't react with anything, meaning that they don't bond with anything either. So this one, what basically it's saying is that ideal gases have the least IMF. And so
Uh-huh.
the most opposite of that would be the most IMF.
Yes.
Okay, so right here from this table, can we tell which thing has the most IMF? Which has the strongest intermolecular force?
The carbon monoxide.
Not the carbon monoxide.
Nitrogen, H3.
The ammonia.
Ammonia
Ammonia.
has what kind of force?
Oh, because it's got a hydrogen bond.
Hydrogen bond. Okay, so we're gonna put NH3 because we have hydrogen bonds right there. Okay, now what about the carbon monoxide?
That's going to have a bipole.
It does have a dipole.
So it's going to be the next.
So we'll put CO right there. Okay, now the question is of these 3. Do you remember what I said earlier? About how the number of electrons affects
Oh, yeah. Uh-huh.
how much dispersion
sense.
forces it can have?
Uh-huh.
So which of these 3, all having dispersion forces, which one has the most dispersion force?
The nitrogen gas.
The nitrogen, because it has 10 electrons. So
The
N2,
more electrons, the more.
The more likely that they're going to rotate to
That
one
they can
side of the
shift.
shell.
Oh,
And
okay.
they can
okay.
shift.
and then we're going to have neon, and then helium. Helium's going to be the most ideal gas.
Okay.
Sweet.
Fun stuff.
How, for the ions, how well do you need to know the ions?
You should be very familiar with them.
So probably ask us.
Polyatomic ions.
Yeah, just
Yeah.
you got to
We were
remember
told
like
we had
the
those memorized.
Looked at them.
you're definitely there's definitely going to be questions on that. It's going to ask you, okay, like what is the structure of, let's say, I mean they are going to give you a periodic table, but let's say they ask you what's the structure of gallium nitrate. Okay, so I mean what's the chemical formula for gallium nitrate? Okay, so gallium, you look on the periodic table, you see it's in the 3rd column. So you say, okay, gallium is most likely going to have a charge of 3 positive. Okay, now nitrate. Nitrate has a charge of what?
Minus.
Is it -1, -2, -3?
What'd you say?
Nitrate.
Nitrate. Just -3.
-3? See, you get that wrong.
Yeah,
Because
I-
nitrate
Yeah.
Just negative.
is a charge of -1. Okay? So knowing that nitrate is charge of -1, that means that you would have to have 3 nitrates for every gallium. So you would write it as gallium, parentheses, nitrate, 3.
So 3.
Okay.
So-
I will be memorizing these over the weekend.
Yeah.
You gotta know
cards.
those. You gotta know.
So you need to know the charges and how to write the formula for like hypochlorite.
Yeah, hypochlorite, HClO.
It says just ClO.
Oh, ClO.
Hypochlorite.
Yeah.
ClO.
ClO.
Yep.
Oh yeah,
Okay.
that's right. ClO. I'm thinking.
Cool.
Awesome.